Hey guys, today we are going to look at similar right triangles, and we're going to show how we can take apart one big right triangle and form two smaller right triangles that are all similar. And that's exactly what this theorem says. It says if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So here's our original triangle. It's the full ABC. And then we've taken apart by drawing this altitude CD in. So you can see CD is right here. And we formed two more triangles out of there. So ACD and BCD. So in these blanks it says triangle CBD is similar to triangle ABC. Triangle ACD is similar to triangle ABC. And triangle CBD is similar to triangle ACD. So one way to identify the similar triangles is to flip them around, make them look like they're facing the same direction. If we go back to this original example, if I look at the big triangle, this is my short side, this is my long side, and this is my hypotenuse. Notice the altitude doesn't play into anything in the side length of that big triangle. But if I look at this medium-sized triangle, this is the short leg here, this is the long leg here, and this is the hypotenuse. So the hypotenuse of this triangle is AC. If you look back at the original picture, AC was the long leg of the big triangle. If we look at the one on the right, the CD that was the altitude is actually the long leg. BD is the short leg, and then BC is the hypotenuse. So all of them are serving different purposes. Again, BC being the hypotenuse. If you look at the original triangle, it's the short leg. So one way to help is to make them all face the same direction. So we took this triangle apart and put it in three different triangles, but then we faced them all the same direction so that the short leg is standing straight up, and so we can see them looking the same. So then we can just go around the triangle in the same direction to know what is similar. So if we say triangle FJG for the first one, then we have triangle GJH for the second one, and then finally we have triangle FGH when we've turned and made them all the same orientation. Okay, so let's try one of those. It says identify the similar triangles, then find the value of x. The first thing I do is map out the three triangles and set them up. And I make it very obvious that there's one leg that's longer than another. So there's my big triangle, the original triangle. Then I have a medium triangle. And then I have a baby triangle. Notice I have the short leg standing up, the long leg down on the horizontal. So if I look at first the big triangle, so I'm just looking at this triangle, DGE. I think the easiest way to start drawing this is I know that point D is the right angle. Then I want to look, so the short side is DG. So if the short side over here is standing up, then I'm going to put G there, and then my other point is E. Now I can fill in the pieces. So DG has a length of 6, DE has a length of 8, and EG has a length of 10. Now let's look at the medium triangle. So I'm going to trace this in a different color. So the medium triangle is right here. So again, the right angle is point F. That's where I typically start. The shorter side looks like it's DF, so D is going to go right here, and then my other point is E. And there's a bell. So DF has a length of X. DE has a length of 8. Notice it's that longer side in that triangle up above. And then we don't know FE. We know that the whole thing, GE, is 10, but we don't know what FE is. So I'm just going to leave that blank. Okay, so then in the baby triangle, if I trace it right here, my right angle, again, is F. Then the shorter side is FG. And the longer side is FD. So I'm filling in the pieces. FD is X. FG, we don't know, so we can't put anything there. And then DG is 6. Okay, so now that we have those 3 similar triangles, we can find the value of X. So what you want to do is find a pair of matching sides that has numbers there, and then find a pair of sides where one is known and one is not. So I'm going to start with the big triangle, and then it doesn't matter whether you choose the medium triangle or the little triangle. But I start with the big triangle and the medium triangle. I know I want to find X, so I know that's one that I need. So I'm going to pair that up with 6. So I'm going to put 6 over X, just like we've done before. Now that we've matched them up, they match piece by piece. So 6 over X, so top triangle to middle triangle. And then I need to go to somewhere else in the triangle where I see that both numbers are there. The only spot I have that is in the hypotenuse, because FE in that medium triangle is not filled in. So I have 10 over 8. From there, we can cross multiply. So we have 10x equals 48. Divide by 10 on both sides. So x equals 4.8. That's all it asked us for, was to find that value of x. Okay, we have a couple theorems that we're going to look at. We're going to look at a theorem, and then we're going to jump to an example. We'll look at another theorem, and then we'll jump to another example. So the first theorem we're looking at is the geometric mean theorem of the altitude. So it says, in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into 2 segments. The length of the altitude is the geometric mean of the lengths of the 2 segments. Okay, so that word geometric mean, we're going to talk about more in class, but when we're setting up a ratio, what it means to us is that those are the pieces that go across from each other. So the altitude is going to be the top of this one, and it's going to be the bottom of this one. And then the other pieces are the 2 parts of the hypotenuse. So part of hypotenuse and other part of hypotenuse. So when I fill this in with an actual example, I'm going to use this one. My altitude, remember, is coming straight down the middle. Now we're just looking at the big triangle in this case. So CD is the altitude. So I'm going to put that in those spots. And then I want one part of the hypotenuse. So my whole hypotenuse is AB. But I want just the part to the left of the altitude, and then I want just the part to the right of the altitude. So I have AD, and I have BD. That's how you set that one up. So now if you'll flip over in your notes, we're going to look at this first example. So it says to set it up so the altitude is the geometric mean, so that's the piece that goes across from itself. And then we take the 2 parts of the hypotenuse, so 6 and 8. from there we can solve. So we do x times x is x squared, 6 times 8 is 48, square root on both sides. So we get x is the square root of 48. We're going to start thinking through simplifying radicals. So my perfect square that will go into 48 is 16. I have 3 left over. 16 times 3 is 48. So square root of 16 is 4. And I have radical 3 left over. Okay, so that's using our altitude theorem. Let's go back and look at our leg theorem. Here's what our leg theorem says. It says in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into 2 segments. The length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse in the segment of the hypotenuse that is adjacent to the leg. So what that means is we're going to set up the leg as the geometric mean. So the other one was called the altitude theorem. We set that up across from itself. Then we're going to put the whole hypotenuse on one side. And then we're going to put the part of the hypotenuse touching the leg on the other side. So we're going to do, we have 2 different legs in a right triangle. We're going to do this twice. So let's start with AC being our leg that we use. So AC goes across from itself. And then I need the whole hypotenuse. So the whole hypotenuse is AB. And then I need just the part of the hypotenuse that's touching the leg. So AD. Erase this so we can do another one. Our other leg then is BC. So that's going to go across from itself. So BC is the leg we're using. I need the whole hypotenuse, which is still AB. Then I need just the part of the hypotenuse that's touching that leg. So BD. Okay, let's flip over again and let's try another example. So in this case, we want to find Y. So Y is the leg. So I'm going to put that across from itself. And then the whole hypotenuse is 15. The part of the hypotenuse that's just touching that leg is 4. So I have y squared equals 15 times 4 is 60. I'm going to do square root of both sides. So then I get y equals, and when I take the square root of 60, the largest perfect square I can take out of there is 4. And then I have 15 left over. So the square root of 4 is 2. And then I have radical 15 left over. So there's my answer. We'll do one more problem here in the notes, and then we'll talk about this in class again. We're going to spend quite a bit of time on this. Okay, to find clearance under an overpass, you need to find the height of a concrete support beam. Use a cardboard square to line up the top and the bottom of the beam. Your friend measures the vertical distance from the ground to your eye and the distance from you to the beam. Approximate the height of the beam. So we want to know the whole height of the beam. Right now we're just going to get this part out of it, and then we'll find that whole height later. So what you want to look for is, what do I have labeled? Do I know any of the legs, or do I know the altitude? And in this case, it's the altitude we're dealing with. So we're going to use that altitude theorem. So we put 6.9 across from itself. And we put the other 2 pieces of the hypotenuse across. So I get 5x equals, and 6.9 times 6.9 is 47.61. We're going to divide by 5. And we get x is approximately, or is equal to, actually, 9.522. But then we need to add that other 5 feet. So 9.522 plus 5 is 14.522 feet.